I'm going to factor this completely. I am.
Sure?
I'm going to try my best. Now, to factor completely, I need to go through all my different forms of factoring. And the first thing I look for when I factor is...
Greatest common monomial.
Miles Brown.
GCM. Thanks, Steve.
I do not look for Miles Brown. So, what goes into all three of these terms? I notice there's a k, and I notice there's a 5. They're all divisible by 5, so 5k goes into all of them. And since I'm such a sensible individual, I see that we have the squared term, and I don't really like to have. But I have the squared term here, and this is not in descending degrees of k now, is it? So when I rewrite this, I'm going to have it in descending degrees of k, because it makes my life for factoring a little bit easier. So k to the third is still my largest degree, because 3 is bigger than 2 and 1. So 10k to the third divided by 5k is simply 2k squared. Now, this is my second largest term in degree of k, because 2 is bigger than 1. So 35k squared divided by 5k is going to be 7k. And this is a negative, so negative divided by positive is a negative. Finally, 25k divided by 5k is just going to be 5. So, since I still have a squared, there's a chance I may be able to factor this again. I'm willing to bet it's going to be factorable again. And so, is this a difference of squares? No, because 2 is certainly not a square, neither is 5. Is this a square binomial? No, same reason. So I'm going to have to factor this as a binomial pair of factors. So I'm going to set up my binomial pair of factors, and right away I notice that 2 plus 5 is 7. And this is a positive, and the linear term is negative, so I know that I'm going to have 2 negative signs, and I really want to make it so that I have 5 and 2 added together, but not multiplied. So I'm going to go with 5k and k, and remember we want the 5 added, not multiplied, so the 5 and the 2 need to be in the same parentheses. And 5 times something is 5. Oh, it's 1. And so just to double check, I'm going to multiply out my linear term and see if the sum is equal to my linear term here. 2k times negative 1 is negative 2k. Negative 5 times k is negative 5k, which is equal to negative 7k. Oh, it works. Therefore, this is my final answer. And I will go on to the next problem.